Hi everyone, in this video I'm going to be talking about some very important topics which are not there in NCERTs but very important topics of some basic concepts of chemistry. Okay, so the first one out of these three is your EMM or effective molecular mass. Okay, the second one is percentage purity. Okay, and the third one is your percentage yield. So, a lot of questions can be asked from these three topics, and that's why discussing them is most important. But the first and the foremost thing which I'll say before I start discussing these topic in detail is that we should have a prerequisite of whatever that is done in NCERT. NCERT of some basic concepts should be on our tips, and we should know what is stoichiometric calculations and how do we go about solving any stoichiometric equation that we have, be it limiting reagent, elemental analysis, whatever. Okay, and the most important thing is balancing. Okay, I can't stress it enough that whenever we have questions related to any stoichiometric analysis, okay, be it all these three or we have anything, okay, whatever we have studied in NCERT, we should always work with a balanced chemical equation, otherwise we should not. Okay, so the first thing which you should which you should see is whether your or not your equation is balanced. Only then you move ahead. Okay, so the first one is your EMM, which is your effective molecular mass. Okay, I just write it, effective molecular mass. And the formula of effective molecular mass EMM is total mass, okay, of the sample in grams divided by total moles of the sample. So, well, EMM is one such calculation which we always do for a mixture of gaseous for a gaseous mixture sample. Okay, so whenever we have a mixture of gases, only then sometimes the examiner can ask about the EMM of the gaseous mixture. We also sometimes use it when we do the next chapter, which is the gaseous state. So that's why the calculation is very important. So we just have to memorize the formula, and there's no rocket science here. So we'll just practice one numerical and we'll call it a day. In a container, we have 16 grams oxygen and 56 grams nitrogen. Calculate the EMM. So I think it's quite simple. We have a formula of EMM as total mass, okay, in grams divided by total moles. So total mass we already have, which is 16 plus 56. All we have to do is we have to calculate total number of moles and divide these two together. So first we'll find out the moles of oxygen, okay, which is, and always remember this is oxygen O2. Okay, so don't write the molecular mass as 16, it is actually 32 because it is oxygen gas. So oxygen in gaseous state is in the form of diatomic, in a diatomic form, which is O2, right? So it is moles is equal to given mass, which is 16 upon molecular mass, which is 32, 0.5 moles, right? And if we talk about the moles of nitrogen, it is, the given mass is 56 upon molecular mass is 28, which is 2 moles. So the EMM is quite simple. We have total mass, which is 16 plus 56 divided by total moles, which is 0.5 plus 2. This comes out to be 28.8. So the EMM of a mixture of 16 grams oxygen and 56 grams nitrogen is 28.8. Okay, so I don't think it's a very difficult calculation, very simple formula, and just the application part is important. Okay, and we have to know, we should know how to calculate the number of moles, and we are done. Next question is this one, and this is a try yourself. Okay, so if you know what is, if you have learned what is EMM, and if you know what is equimolar ratio and equimass ratio, I think it's very easily, you can very easily calculate the EMM of these two. It's a good question, you should try it, and if you have any doubts, of course, you can ask. Next topic which we have to understand is percentage purity. So when we talk about, of course, in chemistry, we talk about drugs, pharmaceutical drug synthesis. Okay, in that case, whenever we talk about formation of drugs, the entire drug which is synthesized is not pure. Okay, there are certain pure and impurities in the solution in the drug formation, and not just in drugs but also in general chemistry. When we talk about synthesis of any new reactants or products, some amount of the synthesized mixture can be pure, and of course the other half can be impure. So percentage purity is very simple. It is the pure sample, amount of pure sample in grams divided by total sample, right? Multiplied by 100, because since it is a percentage, so it has to be multiplied by 100. Okay, so a very simple question we have here. A 12-gram sample of a pharmaceutical drug contains 11.57 grams of active drug. Calculate the percentage purity. So active drug is the only, is of course the pure drug, right? Because if it's pure only, then it's active. So percentage purity is very simple. It's 11.57. This is the pure part, divided by total part, which is 12 into 100. Okay, so you can just do this calculation and you can get the answer to whatever percentage you get, and that is your percentage purity here. Okay, so you can get this question in different forms. All you have to remember is that pure part is going to be on the numerator and total part is going to be in the denominator. Multiplied by 100, you have the percentage purity. Now we have the last part, which is percentage yield. Okay, so as I said, in chemistry, when we talk about synthesis reactions, okay, so let's say we have a reaction 2A changes to B, okay, where 2 and here 1, they represent the stoichiometry of the reaction, that 2 moles of A are going to convert to 1 mole of B, right? But when you actually go in the lab and perform the reaction, you can see that if you take 2 moles of A, they will not convert to exactly 1 mole of B, but it might be a little less than 1 mole, okay? It can be 0.98 mole, it can be 0.99 mole, it can be 0.9 mole, zero point 0.7 mole also sometimes. Reason being that whatever you do is not perfect, okay? There must be some errors which you perform, some errors which happens due to whatever reasons which are there in the lab, natural reasons, and that's why the amount that you should get is a little less than the amount you expect of getting from the stoichiometric calculations which you know, right? So percentage yield is that only. It is actual yield which you actually get in your lab, divided by the expected yield. Expected yield is something which you expect, which means you already calculate based on your stoichiometric calculations, which you can do based on balanced chemical equations. Always remember, okay, expected or theoretical yield. Theoretical means which we theoretically calculated into 100. So it's very simple, right? Now we have a question which is this. We have in a reaction 30 grams of CaCO3 converts to 15 grams of CaO. Calculate the percentage yield. So first we have to write the balanced chemical equation. This is CaO. So the equation is CaCO3 converts to CaO plus CO2. Okay, so I'll just delete this. Okay, now this is a balanced chemical equation. This is already a balanced chemical equation, so I don't have to balance it enough. Now if I just calculate the mass here, it is 40 plus 12 plus 3 into 16. Okay, this is 16, which is 100 grams, and this is CaO, which is 40 plus 16, which is 56 grams. Okay, so just applying unitary method, we have 100 grams of CaCO3 converts to 56 grams of CaO. Okay, 1 gram will convert to 56 divided by 100, and we have, I guess, 30 grams, right? 30 grams of CaCO3. So according to this calculation, I think we get the answer to be as 16.8 grams. Okay, so now we expect 16.8 grams to be formed in a reaction. If we are taking 30 grams of CaCO3, this is CaCO3, right? I'm so sorry. So if you are taking 30 grams of CaCO3, you expect 16.8 grams of CaO to be formed, but you actually get only 15 grams. So now your actual yield is 15 divided by 16.8 into 100, and you get, I think, 89.2% as your answer. Okay, so these were the 3 main topics which I wanted to discuss without ending this entire unit. If you have any doubts, you can ask, and thank you so much for watching. Stay tuned for more.